Hey everyone. So this is lesson 3.2 in Algebra 2. So we're going to talk about we're talking about properties of exponents and the laws of exponents. Today we're going to talk about dividing exponents. And so our overall goal, with all of this unit is to simplify expressions using simplify expressions involving exponents. So we want to be able to just deal with exponents, know how to deal with them, know how to simplify them and work with them. And understand what that notation means. Okay, so today we're going to dividing expressions that have exponents. Yesterday we talked about multiplying expressions. Multiplying and dividing are a lot of times they're seen as the same process, right? Dividing, what we're really doing is we're multiplying by the inverse of a number, and so we'll actually kind of touch on that a little bit as well. Okay. So just to kind of clarify, so we're talking about dividing things, right? When we have something divided by itself, that's always 1. So 4 divided by 4 is 1. Think about this in terms of exponents. This is 4 to the first and 4 to the first. Okay, so this is a 4 divided by a 4, and so that's going to be 1. All right, pretty straightforward. 4 squared, 4 squared. So we could expand these out. We could say 16 divided by 16. Well, that's 1, right? But another way to look at this is 4 times 4 divided by 4 times 4. And we saw up above here that 4 divided by 4 is 1. So if we look at this part right here, right, this is just 1. And this is also 1. And so here we get 1 times 1, which is just 1. So again, just another way of kind of thinking that or visualizing those numbers. So we get to variables. Variables just represent numbers. So generally the rules for the numbers will apply to the variables as well. Something divided by itself is always 1. Again, you think of this as x to the first divided by x to the first, and that's going to be 1. And the same thing here. Again, you can think of this as x times x divided by x times x. And so this x, these x's make 1, these x's make 1. We get 1 times 1, and we get 1. Okay, so we get to what we're talking about today. Here I have these x's, right? And I have 2 different exponents. So this is x to the third on the top and x squared on the bottom. And so how do I go about figuring that out or simplifying that? So I'm going to kind of go back to this. I'm going to think of this as x times x times x, right? So I have 3 x's multiplied together, and then I have 2 x's multiplied together on the bottom. And so if I go to that canceling thing, those x's make 1, those x's make 1, and so I end up with 1 times x, which is just x. Okay, now we can work through that process, pretty easily on most problems, but that idea of writing those out and canceling them out is kind of ridiculous. So, I mean, that's a lot of writing for a lot of these things you can do in your head, but if we can come up with a general rule for how to do this, right, that would be a good thing. So if I look at this example right here, it's just the same thing here, but it's just flipped over. So I've had x times x on the top, 2 x's on the top, and I have 3 x's multiplied together on the bottom. And so again, I get 1, this is 1, and so I have 1 on the top and x on the bottom. So this is 1 over x. Now, a really common thing that people will do is to say, well, all the x's are gone on the top, so that's 0, and so this is 0. No, the x's aren't 0. The x's are 1s, right? They turn into 1. This is x divided by x, that's 1. X divided by x is 1. And so we have 1 in the numerator and an x in the denominator, and so we get 1 over x. Okay? So if we look at what we're doing here, we're canceling out the x's that they have in common. So there are 3 x's on the top, there are 2 x's on the bottom. Well, 2 of the x's on the top will cancel 2 of the x's on the bottom, and I'm left with just a single x on the top. So I'm canceling, or actually I'm looking at the difference between these, right? There's 3 on the top, there's 2 on the bottom. That means that there's 1 extra 1 on the top. So I have an x left over, x to the first power, right? X to the first power in the numerator. Here I have just the opposite. Here I have 3 on the bottom in the numerator, in the denominator, 2 in the numerator. And so I can look at the difference. I have 1 more x in the denominator than I have in the numerator. So that's what I'm going to end up with. I'm going to end up with 1x in the denominator. Okay, and so I would say that that's x to the first. Okay. So we can talk about this as a general rule. They call this the quotient of powers property. It really just means dividing exponents, right? So when you're dividing exponents, again, you have to have the same base, right? The same base. And then once they have that same basis, you can just find the difference of the exponents, okay? In this example, this is assuming that, you know, that m is bigger and n is smaller, right? But really that what's going to happen is wherever the bigger exponent is, that's where your variable is going to end up. So if you have a bigger number for the exponent in the denominator, your x is going to end up in the denominator. Right? So if we look at some quick examples here, again, I could do this numerically. I could say 2 to the 4th, 2, 4, 8, 16. So that's 16 divided by 4. This should work out to be 4. But if I use the dividing exponents, right, the rule for dividing exponents, I can just simply subtract these. These have the same base, 2, and I've got a larger exponent in the numerator, so my answer is going to be in the numerator. And then 4 minus 2 is just going to give me 2. This is going to be 2 to the second power, which is 4. Okay. This one, same thing. I've got the same base. I've got a larger exponent in the numerator and a smaller exponent in the denominator, so I can just find the difference. This is 6 minus 3. This is 10 to the third. 10 to the third. And we go ahead and expand that out. Remember that when we have numbers to an exponent, we want to go ahead and expand those. They call that simplifying. So this is going to be 1 with 3 zeros. So that's going to be 1,000. And then if I look at this last example here, here I've got negative 3 to the 9th and 3 to the 4th. Now remember from our examples yesterday, right? We had this negative. This just means negative 1. So this is negative 1, right? Whoops, negative 1 times 3 to the 9th over 3 to the 4th. Okay, so this negative 1 is just going to stay on there. So this is negative 1. And then I can just evaluate this. So this is 3 to the 9th and 3 to the 4th. There's 9 on the top. There's 4 on the bottom. That's going to leave me 5 3s on the top. So 3 to the 5th power on the top. And then I can figure out what 3 to the 5th power is. And if I'm smart about this, I can open up my calculator, which I had open a little bit ago, and I'm not sure where it went to. But I do have a Desmos calculator up here. I'm going to put that in a separate window so I can easily switch back and forth here. And go back to my example. And so I'm looking for 3 to the 5th power. So in Desmos, I'm just going to go 3, and then this exponent key here, and then to the 5th power. Okay, so 243. So this is going to be 243. All right. So again, with numbers, and then it's 243, but it's also 243 times negative 1. So I actually messed up here. This should be, now I messed it up, so I got to clean it up here. So this is going to be negative 243. So negative 1 times 3 to the 5th. Okay. Again, really common mistake here. I got so excited about 3 to the 5th that I totally neglected my negative 1. So important to write out your work, important to kind of check your steps and make sure your answer makes sense. Okay. Just for fun, in Desmos, I'm going to put in negative 3. Whoops, I'm going to clear this. I'm going to put in negative 3 to the 5th power and see what I get. And that actually works out. Now, the reason that works out is because it's following the same order of operations. It's doing 3 to the 5th and taking the negative of it. But in this case, if I happen to put this in parentheses, right, oops, negative 3 negative 3 to the 5th power. In this case, it also works out to be negative 243. And the reason for that is because when I take a negative 1 to an odd power, I get a negative number. So, okay, and then if we look at some examples here with variables, it kind of works the same way. A to the 4th on top, a to the 2nd on the bottom. That's just going to give me a to the 2nd power. So look at the difference here. I've got 4 on the top, 2 on the bottom. I've got 2 more on the top, so I got a to the 2nd on the top there. This one, I'm just going to go through each one of these variables individually and kind of work this through. So I've got x to the 6th and x squared. And so on the top, right, I've got more x's, so there's a difference of 4. So I'm going to get x to the 4th on the top. And then on the y's, I've also got more x's, or sorry, more y's in the numerator. So this is y to the 1st power. So I have 4 on the top and 1 on the bottom. So that gives me 3 left over on the top. Okay. And there's nothing on the bottom here. This is just works out to be a 1. These canceled out with these other ones and made a 1. And so this is just x to the 4th, y cubed. And then another quick example here. I'm just going to do the numbers first. So I've got negative 10 and negative 5. Negative 10 divided by negative 5, negative divided by negative is just positive, so it's going to give me 2. Okay. And for the a's, I've got 1 in the numerator and 4 in the denominator. I've got more in the denominator, so my a's are going to be there. So I've got 4 minus 1 is going to be a to the 3rd power. And then I've got b to the 7th and b to the 6th. So b to the 7th is bigger. It's in the numerator, so it's going to end up, so this is going to be b to the 1st. So I can just write that as b. So I get 2b over a cubed. Okay. I wanted to talk about one other thing, and this actually goes into the questions that we're going to look at tomorrow. But I noticed that in the homework, whoops. Anyways, here's a brief kind of overview. So this is kind of what we've talked about already. So I'll leave that up there for a second. And what happened here? Okay. Sorry about that. So in your assignment, right, you're going to see some problems that and lost my window here. So in your assignment, you're going to see some problems that that actually have one other component to them. And let me see if I can find an example here. This one right here. So if I look at this, this is z to the 3rd over 5 to the 3rd power. Now this actually gets into a different topic, and but it's not a difficult thing to do. This is what we're going to talk about tomorrow. This is powers of powers, and what this just means is that I'm just going to take everything inside here and raise it to the 3rd power. So if I have z to the 3rd power, right, z to the 3rd power, so I have z to the 3rd power over 5, and then all of that's raised to the 3rd power. Now let's think about what this means. It means that I'm going to take z to the 3rd power and I'm going to multiply it together 3 times. So this is going to be z cubed times z cubed times z cubed. And on the bottom, it's going to say, well, take this 5 in the denominator and multiply it together 3 times. So I got 5 times 5 times 5. So that's literally, you know, what this 3 up here means. It just means multiply z to the 3rd over 5 together 3 times. Okay. So when I do this, well, we know from yesterday that if they have the same base, we can just add the exponents together. So the same base being multiplied together, I can just add the exponents together. So I've got 3, 6, 9. So I've got z to the 9th power on the top here. And then on the bottom, I have 5 to the 3rd. And so I'm going to go back over to my calculator here. And I'm going to do 5 to the third power. And that's going to give me 125. So it's z to the ninth over 125. Okay, so we'll talk a little bit more about this, but I did notice that there's a couple problems in the homework that actually touch on this. So I just want to kind of give you a heads up on that. And I'll go ahead and stop the video here. Let me know if you have any questions.